Hello, my name is Samara Seda, and today I will be presenting you my progress presentation for my final project for the Masters in Engineering Management. My project is titled The Feasibility of Installing a Green Roof System in a Public Institution as a measure to mitigate large water runoff. The agenda for this presentation is shown in this slide. I will briefly discuss the statement, objectives, and methodology as a matter of reviewing. The project timeline will be also discussed. Then I will follow with the progress updates that includes the field visits, the runoff analysis, and the roof load capacity analysis. And then I will mention the activities and the schedule for the remaining of the project and the closing statement. My project focuses on finding a solution for a flooding problem that XYZ, a public education institution, has been having for a long time. The area where the flooding occurs is a parking lot, and the nearby also areas, including the parking lot, are urban, which means that the surfaces are mainly impermeable. That means that in the event of heavy rainfalls, the water has nowhere to infiltrate through or drain through and causes flooding. In the previous presentation, I mentioned several alternatives for this problem, including installing a rainwater harvesting system, a green roof system, and installing pervious asphalt on the affected area. However, during my research, it came to my attention that the area of the parking lot is of 477,000 square feet. And a basic price for pervious asphalt is of $5.50, which would give us a cost of $1.5 million without taking into consideration any subgrade or subbase work and the removal of the previous material. So it would be a lot more. And in the previous presentation, one of the constraints that I mentioned was that there was a limited budget for this project. So therefore, this alternative is to be eliminated. As I already mentioned, the objective is to determine the physical feasibility of locating a green roof system or any other system like the rainwater harvesting system in a building next to this affected area with the purpose of reducing the water runoff and to determine the economic viability of implementing such systems. The methodology that was traced was to determine the impact that the impervious surfaces have on the affected flooding area, to determine the water runoff, the kind of vegetation that will be most appropriate given the green roof system is selected, and the maximum load capacity, and then to perform an economic analysis. This is the project timeline. The project started on January 8th, and on January 31st we had the first visit where pictures and measurements were taken. Then on February 15th the second visit was conducted where precipitation readings were taken on the site, and today is where the blue flag is at. And visually we could say that we are 2/3 completed of the project. Now I will discuss the progress updates up to today. These are some pictures taken on the first field visit of the green roof where the green roof will be located at. This is how the conditions of the roof now. And with the measurements that I took, this is a site layout of the roof that comprises 5,857 square feet. The runoff analysis was completed with a tool from the National Oceanic and Atmospheric Administration, known as NOAA. This tool is called the Atlas 14. With the coordinates of the site, I was able to obtain a lot of data, including graphical precipitation frequency estimates with 90% of confidence intervals. With this graph, we can see different scenarios of rain for this particular site. In this site, anything from 5 to 3 hours of rain is pretty common, and its reoccurrence is yearly, so it will be the green line. The graph is not very good for estimating precipitation depth, but I would say 2.5. However, the tool also gives a tabular precipitation frequency estimate that for a 2-hour rain event will be 2.62 inches of rain in this area. That is what I'm saying in this slide. These pictures were taken during the second field visit, in which it was actually raining, and the purpose of this field visit was to measure the retention on the roof. And I was there for 2 hours, and 325 milliliters of water were collected in a container with an area of 729 square centimeters. The amount of rainfall that day was of 0.08 inches, which might sound like a little bit, but readings were taken in February, which is considered as a dry season. However, the retention was estimated taking into consideration that 50% of the water will retain and 50% will be lost. This would represent that in 1 hour, 105 gallons can be collected. And based on this, the water that could be caught from rainwater harvesting could serve for irrigation purposes. And I am recommending a 1,000 gallon capacity tank with specifications of 64 inches in diameter and 80 inches in height. And this tank has a cost of $559 plus tax and shipping and handling. The roof load capacity analysis was started. Green roofs are defined as green spaces that are created by adding layers of growing medium and plants, which have a purpose of filtrating, absorbing, and retaining stormwater. And that is what we want, to reduce the stormwater that reaches the flooding area that is very close to this building. Green roofs vary a lot in weight, and this depends on the depth and the material used on the green roof. And the important measurement that needs to be considered is the wet weight. There are two types of green roofs, the extensive and the intensive. Extensive green roofs have little load bearing capacity. These roofs are not meant to be used as roof gardens because they have a substrate layer that is not very deep. Therefore, the plants that can be grown there are smaller, like sedums, herbs, meadows, grasses, and perennials. These roofs have lower costs than the intensive roofs, which are roofs that can grow bigger plants such as lawns, perennials, bushes, and trees. In these types of roofs also benches, sidewalks, playgrounds, and even ponds can be installed in. These also require more maintenance and they are more expensive. Therefore, for this project, we will be considering an extensive green roof, which has a soil depth between 3 and 6 inches and a weight of anything between 15 and 50 pounds per square feet. During the next update, I will have already a specific design for this roof. These are the activities and the schedules for the project. As you can see, the roof load capacity analysis is partially completed. Once this is done, I can proceed with the cost analysis, which are the main two activities remaining for this project. So what's next? The next steps will be to complete the roof load analysis, and after I have this, I could be looking into quotes to build the green roof, and based on the quotes and the dimensions, the cost analysis could be completed. And additionally, I will be looking for maintenance alternatives for this project. This is all for today. If you have any questions, please write them below and I will get back at you as soon as I can. Thank you for watching, and I'll see you on the next presentation. Bye.